Today we will be showing you 6 different model equations that describe motion. Here I am drawing a vehicle that has traveled 0 meters at 0 seconds. 10 seconds later it has traveled 100 meters. The first model equation we will be finding is displacement. The model equation for this is delta x equals final minus initial. Since everything is relative to the ground, delta x will be equal to 100 meters minus 0 meters. The displacement when solved will be resulting in 100 meters. The second model equation we will try to find is for the average velocity. This can be found through delta x over delta t, which is the displacement and the change over the change in time. So delta x will equal 100 meters from the first equation we solved, and the delta t will result from 10 seconds minus 0 seconds. When you've mathematically solved this, you will get 10 meters per second.
Now we're going to try to find the average speed of the car. The formula is distance over time. The distance traveled is 100 meters, and the time it took was 10 seconds. We divide these two numbers and get 10 meters per second. Now we're going to find the instantaneous velocity. The equation for this is y2 minus y1 over x2 minus x1. For this, we have created another point at which 5 seconds the car has traveled 40 meters. We're going to plug this in now so that it is 40 minus 0 over 5 minus 0. We're going to solve for this, and we're going to get 40 over 5, which is 8 meters per second.
A student could also be asked to find the acceleration of a moving object. To do so, he would use the formula delta velocity over delta time. As we know, the velocity of a car is 10 meters per second for 10 seconds. So you get 10 meters over 10 seconds over 1 second. After reducing the fraction, the final answer one would get is 1 meter per second squared, which is a proper SI unit for acceleration. In the final question we believe can be asked, one can be told to find, or in this case, confirm the final velocity of an object. We learned of the formula final velocity equals initial velocity plus acceleration times delta time. We created this formula after manipulating the original equation, delta velocity over delta time. Since we already know the final velocity, we will just show that the two sides of the equation are equal. So you get 10, which is the final velocity.